Hi guys, today I wanted to go through a little bit of an introduction to logs. Now, the first thing that I want to talk about with logs is what exactly is it? Okay, students have the tendency when they see log to go, hey, it's a logarithm, what do I do? Well, okay, so don't worry about that. You don't need to concern yourself with the fact that a log is different. Okay, so let's just kind of figure out first exactly what is a log. I'm going to start off as simple as I can. When you had something like this, x plus 4 equals 5, how did you solve for x? Well, there was a plus 4 happening to the x, and so you did the opposite of plus 4, and you didn't freak out because all of a sudden it wasn't plus. You said, oh, well, that's subtract 4. Well, why didn't you have a problem with that? Well, because you're familiar with subtraction. But subtraction is just the opposite of addition. That's exactly what it is. And yes, it's completely different from addition, but it's the opposite. Okay, well, how about this? What if you had x times 3 equals 12? How did you solve for x there? Well, you did the opposite of multiplying by 3. You didn't freak out because it wasn't multiplication. You just said, oh, well, the opposite of multiplication is division. So let's divide by 3. So x equals 4. Okay, well, let's go a step further. Let's make it a little bit more interesting. You have x to the third power equals 27. How do you solve for that there? Well, it's not multiplication, so you can't divide. It's the power. So how do you get rid of a power? Well, the 3, which is the power, is the thing you need to get rid of. So the opposite of doing something to the third power, well, you could do the 1/3 power, or you could do the square root of 3, the third root, and you don't freak out. You just say, well, the third root is the opposite of the third power, right? And so you just do the third root of both sides, and we get the x equals 3. Now, you might say, well, yeah, but no, it's plus or minus. Okay, so it's positive 3 or negative 3. But the idea stands. You don't freak out when all of a sudden you have to put a cube root there. Well, maybe you do, but most people don't. But, you know, if that freaks you out, then you put a 1/3 power, because the 1/3 will cancel out the 3, and you can do it that way. So my point is that there are opposites, and the opposite is different, but it doesn't mean it's something that should weird us out. Okay, well, let me present you with this idea. What if we have 2 to the x power equals 8? Okay, well, if I were to solve this using the same procedure that I did on these, we learned how to do this in the last section, if 8 is a nice square. But what if 8 is not a nice number with 2 as the base? Well, we would have to have some other way of doing it. Well, I need to get x by itself. That's what I did in all of these other situations. I did what I needed to do to isolate x. Well, here I have 2 to the x power. So the problem is I need to get rid of this 2. So doing the square root isn't going to work because the square root gets rid of the exponent. So what do I need to do to get rid of this base 2? Well, really, it's the opposite of an exponential. And what is the opposite of an exponential? It's a logarithm. It's a logarithm. What I'm going to do is I'm going to take the logarithm base 2 of both sides. So I'm going to do log base 2 of this side. I'm going to do log base 2 of that side. I chose base 2 because if the logarithm and the exponential have the same base, they cancel each other out, which means all I'm left with on this side is an x. So x equals log base 2 of 8. Now, if I were to do the log base 2 of 8 on my calculator, then I would find the answer, which would be x equals 3. Now, we'll learn other ways to simplify this and work with it later, but I wanted you to recognize first that's what it is. That's all it is. It's just the opposite of an exponential. Now, this leads us to the basic idea or basic definition of logs, which is if I have a number to the x power equal to another number, then what I can do is I can rewrite this as a logarithm. Okay, you'll notice that the x, which was the exponent, is now the argument. The b, which was the base of the exponential, is now the base of the log. So log base b. And the number that was by itself over here is now the argument for the log. And so log base b of a. Now that is exactly what's given to you on the IB exam, which I meant to show you this right here. On the IB exam you have this, right? A to the x equals b. X equals log base a of b. Now it's the same. I have my letters in different places, but that is the same rule that we're applying right now. So there you go. That's the basis behind logarithms and the base rule that these two are interchangeable. So that means an exponential can be turned into a logarithm can be turned into an exponential. But this is not magic. It's not strange. All it is we're doing the opposite. Okay, so I hope that's helpful. Please watch the second video in which we go into some of the log rules. All right, ciao.